create a truth table for the statement P or Q implies not R implies not Q and P implies R. The first thing when constructing a truth table is to see how many variables we have. I see that here we have P, Q, and R. And again, P, Q, and R also appear on this side, so we have 3 variables to begin with. P, Q, and R. Now to see how many rows we need, remember the number of rows is equal to the number of variables. So we have 3 variables, P, Q, and R, so we need 2 to the 3rd rows. 2 times 2 times 2 is 8. So we need 8 rows in our truth table. 1, 2, 3, 4, 5, 6, 7, 8. And now to begin populating this with trues and falses, the very last variable will alternate between true and false. So we have true, false, true, false, true, false, true, false. The preceding variable will double that. So we have 2 trues followed by 2 falses, and this pattern repeats. The column before that will double again. So we have 4 trues in a row, followed by 4 falses. Now to get going on the remainder of the table, in order to end with this very complicated compound logical statement, we need to break this down into pieces. So if we look at the smallest pieces that we have, in parentheses here, I see that we have Q implies not R. We also have not Q implies P. Those are going to be our next goals, to get those 2 on the truth table. However, before we can get Q implies not R, we have Q already in the header of our truth table, but we don't have not R. So I'm going to put that next. So not R is the next header in the truth table. And to form the next statement, this not Q and P, well, we have P in the header of our truth table already, but we don't have not Q. So we need to include not Q in the table as well. Once we have those ready, now we're ready to put in those pieces that are outlined in red. So we have both Q and not R already in the header of the truth table. So now we can include Q implies not R. We can build this up because we already have Q and we already have not R. For the next header on the truth table, we want to get not Q and P. So not Q and P. We can legitimately put this in on the table because we already have not Q and we already have P. So that handles the next header on the truth table. So now if we go to the expressions in the brackets, this piece here, P or the quantity Q implies not R. Since we already have an entry for Q implies not R in the header of the truth table, and we already have an entry for P, that was back in the beginning, we can put these 2 pieces together. So our next entry can be P or the quantity Q implies not R. So that handles this section in blue. We also want to get this compound statement, the not Q or P implies R. We already have an entry for not Q implies P. That's this column on the table. We already have R back here in column 3. So we have both of the 2 pieces going in. So we can form the compound statement not Q or P implies R. So that handles the second set in brackets, the second blue group. So finally, we have both of the 2 blue pieces. We can now write the big compound statement that was our goal in the beginning. We can now write the quantity P or Q implies not R implies the quantity, not Q and P, implies R. Because we have this first bracketed bunch, that was this column over here, P or Q implies not R. And then the second group in brackets, we have that over here, not Q and P implies R. Now that we have the header of the truth table built, we can start populating the inside using the rules of logic. That takes too much time for us to finish here, but we'll have a PDF download available with an answer key.